adipic acid contains only carbon, hydrogen, and oxygen. Upon combustion of this compound, we will produce carbon dioxide and water. To determine the empirical formula first and then the molecular formula, we will need to calculate the amount of carbon, hydrogen, and oxygen in the acid separately. Starting with 2.960 grams of carbon dioxide, we know that the molecular weight from the periodic table of carbon dioxide is 44 grams. And since there's one carbon atom in a molecule of carbon dioxide, we know that there will be 12 grams of carbon for every 44 grams of carbon dioxide. Canceling out gives us 0.8073 grams of carbon, which is the carbon in our sample. Now we'll do the same thing for the mass of water. We have 1.010 grams of H2O. The molecular weight of a mole of water from the periodic table is 18 grams. And in every 18 grams of water, 2 grams will be hydrogen. And that will tell us we have 0.1122 grams of hydrogen in our sample. Now, since we know the carbon and the hydrogen, we can use that information to determine the mass of oxygen from the original sample, 1.638 grams of the adipic acid. And if we subtract the mass of carbon and the mass of hydrogen, that will tell us how much oxygen is in our sample, 0.7185 grams of oxygen. Now that we know the mass of each element in our unknown compound, carbon, hydrogen, and oxygen, we can convert all three of those masses into moles. So starting with carbon, 1 mole has a mass of 12 grams. And that will give us 0.06728 moles of carbon. The mass of 1 hydrogen is 1 gram. So we will have 0.1122 moles of H. And the molar mass of an oxygen is 16 grams. And that gives us 0.04491 moles of oxygen. To determine the empirical formula, now we need to divide all of our moles by the smallest number of moles. That is the moles of oxygen. So if we divide everything by 0.04491, that's going to give us our ratio. Since we don't have whole numbers, we need to multiply by a number that will give us whole numbers for our empirical formula. We see a 1.5 and a 2.5, so that should indicate we need to multiply everything by 2 to get our empirical formula of C3H5O2. Now that we have the empirical formula, we can get the molecular formula. The problem tells us that adipic acid should have a molecular weight of 146.1 grams per mole. So let's check the molecular weight of our empirical formula to see if we have 146.1 grams per mole. So carbon has a mass of 12 grams per mole, and we have 3 of them. And hydrogen has a mass of 1 gram per mole. And we have 5. And the oxygen has a mass of 16 grams per mole. We have 2. So If we add all that together, we end up with a molecular weight of 73 grams per mole. We can see that the empirical formula does not match the molecular weight of the formula, so we need to figure out how many units of the empirical formula we need. We can do that by taking the molecular weight of the compound and dividing by the empirical formula weight. And that gives us 2, which tells us we need to multiply our empirical formula by 2 in order to get the molecular formula. So we will end up with C6H10O4.